Module 2, Transmission, Distribution, Equipment, and Safety. 2.1 Transmission and Distribution of Electric Energy. Once electricity is generated, it must be transmitted and distributed efficiently. Transmission systems carry electricity over long distances using high voltages, typically between 132 kV and 765 kV. The higher the voltage, the lower the current for the same power, which minimizes losses. Distribution systems reduce voltage through substations to levels suitable for consumer use, such as 33 kV, 11 kV, and down to 400 or 230 volts for household. Transmission lines are usually overhead, while distribution systems may use overhead lines or underground cables, especially in urban areas. 2.2 Current and voltage relations in transmission lines. In transmission lines, voltage and current are affected by the line's resistance, inductance, and capacitance. These properties cause voltage drops and phase shift along the line. Short lines have minimal effect, but in medium and long transmission lines, these relations must be carefully studied to ensure efficient operation. Engineers use models of transmission lines to predict performance and design appropriate compensation methods to maintain voltage within acceptable limits. 2.3 Regulation and losses. Voltage regulation refers to the ability of a system to maintain constant voltage at the consumer end despite varying load conditions. Poor voltage regulation results in unstable supply and damage to sensitive equipment. Losses in transmission systems include resistive losses, caused by current flowing through conductors. Dielectric losses, occurring in insulating materials. Corona losses, discharge effects around high-voltage conductors. Minimizing losses is essential for efficiency, cost savings, and sustainability. 2.4 Construction of overhead lines and underground cables. Overhead lines are the most common method of electricity transmission. Their design considers conductor material, insulation, supporting structures, and environmental factors. Advantages: cost-effectiveness, ease of repair, and high capacity. Disadvantages: exposure to weather, risk of faults, and visual impact. Underground cables are used in urban areas where space is limited or aesthetics matter. They are insulated, protected, and buried. Advantages: safety, reliability, and reduced environmental impact. Disadvantages: higher cost and greater difficulty of maintenance. 2.5 Power system equipment. The power system relies on specialized equipment for efficient operation. Transformers, step-up or step-down voltage levels. Circuit breakers, interrupt fault currents automatically. Fuses, provide simple overcurrent protection. Relays, detect abnormal conditions and trigger protective actions. Switchgear, combinations of switches, breakers, and protection devices. Capacitors and reactors, improve voltage regulation and power factor. Each component plays a vital role in ensuring that power is delivered safely and reliably. 2.6 Standards and safety. Standards ensure uniformity, compatibility, and safety across power systems. Organizations such as the IEEE, IEC, and national regulatory bodies set technical requirements for equipment and operations. Safety considerations are crucial in power systems due to the hazards of high voltage and current. Key safety practices include grounding and earthing systems, proper insulation and clearances, protective relays and automatic disconnection, regular maintenance and testing, training and protective equipment for workers. Safety is not just about protecting equipment but also about safeguarding human lives. In Module 2, we studied the technical aspects of transmission and distribution, the behavior of transmission lines, voltage regulation and losses, construction of lines and cables, power system equipment, and the role of standards and safety. These principles ensure that electric power systems remain efficient, reliable, and safe for consumers and operators alike. Course conclusion. We have now completed the course on Electric Power Systems Principles. Module 1 introduced the fundamentals of power systems, sources of energy, system structure, three-phase concepts, and load characteristics. Module 2 focused on transmission and distribution, current and voltage relations, regulation and losses, line and cable construction, equipment, standards, and safety. Together, these modules provide a solid foundation for understanding how electric power systems are designed and operated to deliver reliable energy to society.